Good afternoon, everyone. Thank you very much for attending this talk. And today I will talk about policy-based management of volume snapshot in Kubernetes. My name is Jing. I'm a Google software engineer working in Kubernetes storage lifecycle group. And my co-author, Anthony, he is also a Google engineer. He is working in Kubernetes workload team. Unfortunately, he cannot join us. And this is Xing. You want to introduce? Yeah.
Hello, can you hear me? Hi, I'm Xing Yang. I work on OpenSDS. I work with Jing on adding snapshot support into CSI, and also add snapshot support in tree in Kubernetes.
Xing and I are leading the snapshot project in SIG storage. So if you have any questions, feedback, in case you don't have time to talk to us, I leave the contact information at the end of the slides. Yeah, your questions, feedback, always welcome. Okay, this is the overview of this talk. As usual, some background, the snapshot, and the concept of cloud volume snapshots and Kubernetes volumes. And with this background, I will introduce the Kubernetes volume snapshot API design and the workflow based on this API. And with the volume snapshot API support, I will talk about how to use Meta controller to design a snapshot schedule policy and how to use controller to manage the policy. The last section, I'll talk a little bit about some related work, specifically the in-place restore workflow we are currently working on. So first thing, why we care about snapshot, I want to use a quote from Tim Berners-Lee, the inventor of World Wide Web. So data is a precious thing and will last longer than the system themselves. However, data is valuable, but the system we use to store data might have problems, either in hardware, like hard disk failure, or in software. So data might be corrupted, and user might also delete their data by mistakes. How we can protect our data, right? This valuable data. So snapshot is one of the commonly used way for this purpose. Basically, it is a read-only copy of the data at a certain point of time. And snapshot comparing to the data copy or data clone, it has some advantages. So it's very fast, and it has typically little performance impact on the running application and consume less capacity. So considering the cloud environment, so we have the concept of cloud volume. So data will be stored on the cloud. And cloud volume basically is very similar to just a normal hard disk. But this can be attached, detached to different virtual machine instances. So user has the flexibility to run their applications different places. So it's no longer tied into a single node. And many cloud providers support snapshot to their volumes. And normally it's fast. It implements as incremental snapshots. And the snapshot data will be uploaded to the cloud so user can access the snapshot. For some cloud provider like AWS, their snapshot is available in a single zone. So user can access that snapshot from that zone. If you want to access snapshot from different zone, you need to copy your snapshot to those zones. And for Google Cloud, snapshot itself already global available. That means you can access your snapshot anywhere you want. As we just mentioned, the snapshot is very useful for protecting your data. And in cloud environment, you can see it's also useful for replicate your data to different places. So before going to the design of volume snapshots in Kubernetes, I will just use a couple of slides to give overview of Kubernetes volume concepts. If you attend Saad Ali's talk early today, you're probably already familiar with those API objects. So in Kubernetes, normally most entities are represented by REST APIs. And for volumes, we use a pair of API to represent. From user point of view, we have persistent volume claim. It is a request for the storage. And a user can specify how much storage they need, what type of storage. It is a namespace API, but API objects. And when user submit such a request, the controller will provision the volume dynamically or might find a matched volume, existing volume, depending the configuration. And the volume information will be stored in another API object called persistent volume. And the controller will bind these two objects together, which means they have pointers to each other. And once those API objects are bound, user can start using those volumes, so they can, in their pod spec, they can reference the PVC. And the life cycle of PVC will be independent to their pods using them. Now I'll show some YAML file to go over the PVC PV as a simple example. So for user, if they want to create and use some storage, they can create a PVC YAML file. It's very simple. In the spec, you specify how much storage you need and the access modes. And when you use kube control to create such YAML file, and a PVC object will be created with the information we just seen. And controller will go ahead to provision a new volume and also a PV API object to represent this volume. You can see the disk information, like the name, will be stored in the PV. And since this is non-namespace API object, only system admin can access this information. And the controller will bind these two objects together. Now the pod spec can start using this piece of storage by referencing the PVC. Now with the concept of Kubernetes volumes, we can go ahead and talk about the volume snapshot API design. So for snapshot workflow, first we want to support create a snapshot. Right? And depending how you prepare your application before taking snapshot, we can have different types. The first is, the simple one is random. So you don't prepare your application at all. And you just take snapshot at a certain point. But because application might continuously writing data onto the disk, and you might have consistent issue. So it suggests to maybe freeze the IOs of your file system to achieve some crash consistency in the file system level. Or for some applications, you might need to pause the application, flush the disk, unmount the disk before taking a snapshot to achieve application level consistency. Currently, in the Kubernetes volume snapshot design, we only support the random, and in the future, we plan to support other types. And once the snapshot is created, it might have additional phase for cloud providers. So for cloud provider, it will upload the volume snapshot data to the cloud too. This might take some time, varies from minutes to even hours, depending on your snapshot data size. But for create snapshot itself, should be very fast. It should be instance. And after taking a snapshot, you can use snapshot to first to create new volumes. And to create new volume from snapshot, that means the data will be populated into the volume. So instead of just the empty volume you create as before. And at the same time, many cloud providers allow you to change your volume configurations. For example, you can change the type of your volume, from standard to SSD, and you can also increase your volume size. So you can see this is also a use case for using Snapshot to change your volume configurations. And delete snapshot is straightforward, right? You can delete your snapshot from cloud. And now, for the API design, volume snapshot is very similar to PV-PVC design. So we also have two API objects to represent it. From user point of view, you have a volume snapshot. Basically, it's a request for taking a snapshot to a volume. So in the volume snapshot spec, you specify you have a reference to the PVC. That means you want to take snapshot from that volume. And once a snapshot is taken, system will create a volume snapshot data API object, which will store the detailed information about the snapshot, like the ID. And controller will bind these two objects together, just like PV-CPV pair. And the life cycle of volume snapshots will also independent to their PV-PVC. And now we also use YAML file to show the workflow of creating snapshots. And you probably see this is a very simple YAML file. And in the spec, you only need to specify your PVC name. That means you want to take a snapshot for that particular PVC volume. And when you use Kube controller to create such volume, such snapshot, a volume snapshot API object is created. And also, a volume snapshot data API object is created in non-namespace. So you will see the snapshot ID and also creation timestamp, etc., the status information in there. And the controller will also bind these two API objects together. Now, after that, you have a volume snapshot API object available. You can use it to create new volumes. So here, you can see to create new volume is almost identical to the workflow we just showed in creating volume before. The only difference here is you specify your snapshot name into the PVC YAML file. And currently, because the snapshots implementation is out of tray, so we use annotation to put this information. You may also notice we add storage class name here because out of tray, we use external provisioner. So you need to specify this provisioner name. Okay, similarly, so a PVC API object is created and also a PV object. And the controller will bind them together. But this time, you will see the data will be populated into the volume instead of creating an empty volume. But for user point of view, the workload of creating volume almost the same. You just add your snapshot information into the YAML file. And in the current state, we have a volume snapshot API support in external storage repo. So all the API objects are actually CRD, custom resource definitions. And we use external controller and external provisioner to manage, to create, delete snapshot, and provision volume from the snapshot. And we are working on pushing this in tray as alpha version and also add CSI support. Okay, with the support of volume snapshot API objects, now we talk about how to use a controller to manage snapshot policy. So just now, when we introduce snapshot workflow for user, right, they create a single snapshot whenever they need. However, in many use cases, system admin want to, let's say, periodically take snapshot, like every day, and also delete snapshot, for example, after a certain period of time. So that means we need a schedule, right? We call it a snapshot policy, and also a controller to react based on this policy. And such policy should be also represented by API object. However, we don't have any built-in API object to represent snapshot policy. So CRD would be very useful for this case. So we can create a CRD for policy type and create policy. But by just creating policies, CRD itself won't do anything. Just like all the other API objects, you need a controller, right, to define, to manage based on this policy. So that is what we call the custom controller. Normally, in custom controller, you need to have some implementations, components such as shared informer, to keep watching the update from the API server, and the reconciler to create a control loop to manage the states. It sounds a little bit work, but good news is for Meta controller, it is framework provided by my co-author, Anthony. And by using the Meta controller framework, all these common components already provided. For user point of view, they only need to create their CRD for their, let's say in this example, the snapshot policy, and also to put their business logic into the sync webhook. And the reconciler will create a control loop on your behalf and call the sync function periodically or when it's needed. So use snapshot policy as example. In the CRD definition, right, you create a new type, which is called snapshot policy. And with this new type, I can create my own snapshot policy, policy 1, and I put in a spec, like snapshot interval, like 6 hours. That means every 6 hours, I want to create a new snapshot. And also validate period, that means after 10 days, I want to delete that snapshot. This selector will match labels. Basically, it will find the resources that have the matching labels. That means it should be controlled by this policy. And let's look at the controller side. So Meta controller provides a few controller patterns. One is called composite controller. Basically, in such controller, you define your parent resource and children resource. And the parent resource, in this case, would be your snapshot policy. And children resource will be the PVC and the snapshots that you want to manage by your policy. And you can also define, like, config how often you want to sync in this snapshot policy controller. And this would be your logic you put in your sync function. Since this is a webhook, you can use any language you want. And in this sync function, it's very simple. So for it will have 2 control loops for each snapshot, like managed by this policy. You check the creation time. If it's larger than the validation valid period, you need to delete this snapshot. And also, it will check each PVC under this policy. What is the creation time for the last snapshot taken for this PVC, and compare with the snapshot interval. If it's longer than the interval, it will go ahead to create a new snapshot for this PVC. Okay, it's time for just a simple demo. To play safe, I will use this video to show you. I hope it's large enough so you can see it. So first, I'll check the controller YAML file. So you have the custom CRD definition and composite controller. You define parent resource, children resource. and also the deployment to run your controller. By use kube control to create your snapshot controller, you see you have CRD created, the controller created, and deployed. And now I create a new policy. In the policy spec, I specify it takes snapshot every 10 seconds, and the valid period is 20 seconds. Now I can apply this policy. And now you have policy and you have controller running. I create just a normal PVC. And in this PVC, I request some amount of resources. And now we can check for volume snapshots. And right away, you see we have 2 snapshots taken already, so every 10 seconds. And also, since we have validated period, 20 seconds, so you see the old one is deleted and new one is created. Now it's time I want to change my policy. So I change from 10 to 5 for the snapshot interval, and the period made it longer to 50 seconds. And I only need to apply this policy again with kube control. And now when you check this, you can see immediately every 5 seconds a new snapshot is taken, and the old one won't delete it until it exceeds 15 seconds. So indeed, it's a simple demo, but from this demo, we see the potential, the possibility, right? You create complicated, high-level policy controller based on your needs. So with Volume Snapshot API and the Meta Controller Framework, it's very easy to create your own. And you can modify your policy file and apply it anytime you want. And you can customize the logic. For example, in the snapshot sync function, you can also trigger a job to prepare your application before taking snapshot, and also resume application after snapshot is created. And also you can manage multiple policies by using the labels, and you can specify which sub-resources you want to manage by this policy. Okay, so now it's the last part of this talk to talk about the restore workflow. So this slide is basically remind you of our creating volume from snapshot workflow. So remember, the only thing you need to do is to add snapshot information into the PVC YAM file. And then the controller will provision a disk from the snapshot, and a new pair of PVC will create it and bind together. However, this simple approach has some limitations. First, you need to modify your PVC source file. In some use cases, that might applicable. And also, for PVC, it's my currently in use. That means a pod might reference it and running your application use this storage. You cannot directly change your PVC and restore your data into that PVC. So some manual step you might need to do is, for example, including delete your pod first, and then you need to delete your old PVC. And pay attention, your original volume might also delete it if your retention policy is deleted. And now you can create, by modifying a PVC source file, you can create a new PVC but with the same name. And after the volume is provisioned and PVC bind together, and you can resume your pod, which reference that PVC. So this whole process, that means you need to tear down your pod, right? So you might have a long downtime because of this. So to overcome the limitations, we propose a in-place restore volume workflow. And we can use a new API object called restore volume. In this API object, you specify what is the snapshot source and what is the persistent, the PVC name. And in case this PVC is currently in use by some pod, and when user creates such restore volume, and the controller will, based on the information, first to provision a new volume from the snapshot and use PV prime to represent it. This step can be done independently. It won't affect the existing PVC. And when the volume is provisioned, after it's provisioned, user can decide to delete the pod, and the controller will detect, not at this time, PVC no longer in use by any pod, and quickly switch the bind pointer to the new PVs. And right after that, your new pod can be resumed. So in this way, you still have your PVC. It doesn't change, but the bind pointer will point to the new PV. And your pods will start using this new volume. And the downtime for your pod is only basically to switch your pointer from the old one to the new one. It should be minimize your downtime. And we consider this in-place restore would be useful for some use cases. For example, you have stateful set, your application is running, but one of the disks has problem. You want to restore from a snapshot. You can just create a restore volume API object to achieve this. And also, it might be useful for like rolling, updating a scenario. Okay, so that's most of my talk. And in summary, so currently we have a out-of-tree volume snapshot implementation in the external storage repo. So for experimental, you can try it. It provides all the basic functions I just mentioned, like create, delete snapshot, and create volume from the snapshot. And currently, we support a few plugins, including GCPD, AWS, OpenStack Cluster, and HostPass. And we are actively working on snapshot feature, for example, to add support for CSI, and also pushing the volume snapshot API in tree, and work on the in-place restore workflow, and provide the snapshot policy controller. So those are all ongoing work, and your feedback and questions are welcome. So finally, this is a teamwork. Besides our Google team, and we have outside contributors from OpenSDS, from Red Hat, and this is our contact information. Yeah, anyone interested, please let us know, and you can involve in this. Thank you very much. So we can take some questions.
Yeah, so I'll just try to talk loud and simple. So concerning the annotation for the PVC, is there a way to be certain that when that PVC is provisioned that it actually is a snapshot as requested? For example, if the snapshot controller is down at the time of the PVC creation, could you actually just have a blank PVC?
No, so to provision volume from snapshots, it actually don't need snapshot controller workflow. It is basically follow the same volume creation workflow. So it will just check your, since you have a snapshot API object, so it will get snapshot API object and find the snapshot ID, and then pass this information to the provisioner, and the provisioner just go ahead to add this snapshot information when create volume. So it's not related to controller, snapshot controller.
Okay, so it's in that part's in tree. So if the snapshot stuff isn't working, your PVC would fail to bind then.
Currently, it's using external provisioner.
Okay.
Yeah. So, but after we move in tree, right, it's basically the same workflow when you create a new volume, right? So it goes through the provisioning workflow. It's not depends on the snapshot controller itself. Snapshot controller will just responsible for creating, delete snapshots. Yeah. Thank you. Yes.
Is it possible, if you suffer catastrophic loss, to reconnect a snapshot that's been taken previously in your, say, a new cluster, in the fact that you've taken an EBS snapshot, if you're on Amazon, and now you're restoring your entire cluster, and now you need to connect that back to the snapshot manager system?
So you mean like you create a snapshot outside, and then you want to make it available in Kubernetes?
Yeah, or you've created it on a cluster that's died, and now you're bringing up a new cluster with this, and it's been created, not known by it.
So I think your question have two aspects. One is do you plan to create snapshots through the Kubernetes API?
Mm-hmm. Yeah.
Okay,
yeah.
So you have snapshot API object available, but you want to use it in another cluster when you bring it up. So as long as your new cluster can access the same API server, right, you have your snapshot API objects available, so you can retrieve from that API server and you can be able to use it, yes.
If the API has died, but you don't have it anymore, but you do have the snapshot, can you get the snapshot?
So then depends.
API object, like
Right,
API.
because currently all the snapshots ID, like information, is stored in the API, in the snapshot API objects. So if you don't have other like record of,
backup basically.
yeah,
Yes, then you can get it.
yeah, you can still, yes. Yes.
Hi. If you have a snapshot taken from the storage system, the external storage system, can you import into Kubernetes and use?
Yes, I think it's possible. We didn't like work on that specifically, but if you have taken a snapshot outside, right,
Yeah.
and you can probably manually to create a volume snapshot API objects and manually put the information into those objects.
Okay.
Yeah,
Okay, thanks.
it's possible, but it may involve some extra work to do it. Yeah.
Thank you. So my question is about the meta controller. Do you recommend creating operators or policies using meta controller? I have been trying meta controller on and off, but it's been a little bit difficult for me.
Yes, I think it's might have a little bit of learning curve, but the good news is like Anthony, who is in charge of this project, he is continue working on that, and also I'll show you. He has a new, like, here. I think he is still working on that, but it's basically have a lot more information how to use the Manta controller, and it has much richer information and help you to understand the workflow. So when I start working on that, also have some learning curve, but after a little bit, I think is give us very powerful kind of framework to work on to design your own, yes. Okay. So I definitely recommend using it, yeah.
Thank you.
You're welcome.
So can we have more than one policy for same snapshot object?
Yeah, you have
So
many
who-
policies,
So
yes.
who will do the policy validation then? Is there any conflict in the policy? Who will do the validation of the policy?
Who will do the validation?
Yeah.
So currently it's just like a small demo working on this. So we don't really have like validation. So what do you mean by validation your policy, like whether it is feasible?
Yeah, maybe you define an interval which is conflicting each other to delete a policy, so to delete a snapshot or creation of a snapshot. So if there is a conflict in the policy, when you define more than one policy for the same snapshot object.
So normally I'm thinking your policy should manage a subset of your resources, unless you have overlap among different policies, right? So each policy should in charge of like different group of resources. And so your policy will depends how you implement your business logic, right? So you can have some validation into your policy, into the business logic you put in the sync function.
Okay.
Yeah.
Yeah, thanks.
Okay, so I think that's the end of my talk, and thank you very much. And so your feedback, questions, yeah, welcome. Thank you.